A smart computer network experiences packet loss due to two possible causes. One is network congestion, that is 60% of the packet loss, and hardware failure, which causes 40% of the packet loss. So these are your two events. So when congestion occurs, packet loss is detected to be 90% of the time. So here, congestion already occurs. Okay, so that is your given condition. During that time, the packet loss detected is 90%. And when hardware failure occurs, so the given condition is hardware failure, so during that time packet loss detected is 50%. Okay, so what you're asked to find is a packet loss has been detected, determine the probability that it was caused by network congestion. Okay, so if you read carefully, probability of network congestion is given here, that is 60%, or you can write it as 0. 0.6. Okay, so probability of congestion we take it as 0. 0.6. Probability of hardware failure, it is 0.4 or 40%. Next, what is given is when congestion occurs, packet loss detected is 90%. So the given condition is congestion, and the second event happening after that is packet loss. So here we are denoting packet loss by the variable L. Okay, so packet loss given there is a congestion is nothing but 90% or 0.9. Next one, when hardware failure occurs, packet loss. Okay, so already occurred event is hardware failure. So when hardware occurs, the packet loss is 0.5. So we'll write P of L given H is 0.5. Now your question asked is a packet loss has been detected. So already happened event is the packet loss has already happened. Determine the probability it was caused by network congestion. So you're finding what is P of C given L. Okay, but in your question, your prior probabilities you're given, the conditional probability you're already given, P of L given C is 0.9. You're asked to find P of C given L. So when the case is the reverse case, you go for Bayes theorem. Okay, so here the total probability should be found in order to solve the Bayes theorem problem. So first we find what the total probability is. That is, what is the probability of loss, packet loss. So according to total probability theorem, probability of loss is nothing but probability of loss given that there is a congestion into probability of congestion plus probability of packet loss given there is a hardware failure into probability of hardware failure. So all the values for the terms here, we have it here. So just put inside the formula, multiply, you'll get the answer. Okay, so once we are done with total probability, this total probability will come as the denominator for your Bayes theorem. Okay, so here probability of, you are asked to find conjunction given packet loss. So according to the Bayes theorem, it is loss given conjunction into probability of conjunction divided by the total probability. So again, all the values are here, and probability of packet loss we found it to be 0.74. So on normal algebraic operations, you get the answer as 0.73. Okay, so this, if we are solving in terms of Python code, means what you have to do is you have to just give whatever we have predefined. Okay, so we have given P of C is equal to 0.6, P of H is equal to 0.4, P of L given C is 0.9, probability of L given H is 0.5, then probability of L, that is your total probability, you define it as P of L into P of C, sorry, P of L given C into P of C plus P of L given H into P of H. Okay, so the equation should be typed. Next one, for Bayes theorem, probability of C given L is nothing but probability of L given C into probability of C divided by probability of L. So once you are done with the equations, in order to for you to display the answer, you give the command print. Okay, so this is the probability of packet loss, so that we are just giving under double quotation. And in order to check with the value, what we do is we give here, here since we need only up to 2 decimal places, we give it as round the total probability value to 2. Okay, likewise, in our question, we are asked to find what is the probability that the packet loss is due to congestion. So that term should be written under the double quotation. And after that, here again, we round it up to 2 decimal values. So we give round off the Bayes theorem value to 2 decimal values. So once you run the program here, you will get the values what we have already solved and we have obtained.